So the next part that we're going to be taking a look at is the section on the alkyl halides. And so we're going to be looking at 4 attachment group, and specifically they are from group 17, which is your halogens. And so you have your fluorine, chlorine, bromine, and iodine. And so in this case over here, if you take a look, we're taking the first part of the halogen name, dropping the ending, and we're just adding an O at the end. So here we have F, which is your fluoro, Cl, which is your chlorine, it becomes chloro, Br is bromine, is bromo, and iodine, which becomes iodo. And the naming rules are similar to what we have taken a look at with alkyl groups. So for example, when we take a look at, let's say, the following carbon chain, so 1, 2, 3, 4, 5, and we have something like an F over here. So again, the rule applies that we find the main carbon chain. So the main carbon chain is found right over here, and we have our attachment group. So there's 1, 2, 3, 4, 5, 6. So this becomes our hexane. And this is your fluorine, which is your fluoro. And so in this case, again, when we do the numbering, we always try to give the attachment group the smallest number possible. So in this case, we can see that it's closer to the right-hand side. So it's have 1, 2, 3, 4, 5, 6. And then we have 1, 2, 3, 4, 5, 6. We see that the 2 gives the fluorine attachment group the smallest carbon location. And so that is the one we choose. So this becomes 2 fluorohexane. Now again, if we look into some other challenges, is what if we have more than one? So if I have the following molecule now, and then what I have over here is I have, let's say, an F, and then let's say over here I have a Br, then again, if it is distributed asymmetrically, then we want to number the main chain over here so that we give these two attachment groups the smallest possible carbon location. So we have 1, 2, 3, 4, 5, 6, 7, 8. And then going in reverse, we have 1, 2, 3, 4, 5, 6, 7, 8. So we see that going from right to left, the fluoro has a 2, the bromo has a 4, but going from right to left, then or left to right, we have 5 and a 7. So the top 2 here is going to be the number that we are going to be using for our attachment groups. And so this becomes, again, listing from the lowest carbon, listing in alphabetical order, the bromo over here is going to come first. Then we have our fluoro. And then over here, there's an 8 carbon chain. So this is going to be octane. So this is going to be 4 bromo, 2 fluoro, and it's going to be octane right there. Now, what if, again, we have something that is distributed symmetrically? So if I was to redraw this molecule, and now over here, I have a Br, and over here, I have an F. And so in this case, I have my main chain, which is right over here. And there's 1, 2, 3, 4, 5, 6, 7, 8. So again, this is an octane. And if I was to write 1, 2, 3, 4, 5, 6, 7, 8, and going reverse, 1, 2, 3, 4, 5, 6, 7, 8, we see that going from left to right, we have Br at the 2, and we have the fluorine at the 7. But going from right to left, we have the fluorine at the 2 and the bromine at the 7. So which one do we choose? And again, if you were to take a look at the molar mass of the bromine and the bromine has a higher molar mass, and so therefore we're going to give that the priority. So as I repeat from previously, for chemistry 11, we're just going to right now look at the mass to give the different groups the priority, but later on there are going to be other considerations for which groups get priority. So once again, because the bromine here is the heavier one, then it is going to have the 2, thus making the fluorine be positioned at the 7th carbon. So this is now going to be 2 bromo, then 7 fluoro, and then you have your octane. So finally, if we have something whereby we have 2 of the same groups together, so in this case over here, if I have something like the following, and I have, let's say, a Br over here, and I also have a Br over here, then what happens over here is I have my main chain, 1, 2, 3, 4, 5, 6. This is a hexane. And I number this 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. In both directions, the carbon that the bromine is on is the 2 and the 5, or 2 and the 5. So it's exactly the same in both directions. So how do I go about naming this? So instead of going 2 bromo, 5 bromo hexane, I'm going to write 2, 5, and then I'm going to write dibromo, and then it's going to be hexane right there. And so here is how we go about naming your alkyl groups, or your alkyl halides that are attached to your hydrocarbons.